Hello students, welcome you to this session. In today's video, I am going to teach you matrix. One of the very simple topic. Matrix or matrices is a plural form of matrix. See, what is matrix? Suppose we have few numbers, for example, 4, 2, 1, 5. I want to arrange them in some proper order. So you can arrange like this itself, 1, 4, 2, 1, 5. You can write arrange in a single line. Or if you want, you can arrange like this, 4, 2, 1, 5. You can arrange like this. Or you can arrange 4, 2, then 1, 5. You can arrange like this. But 4, 2, 1, 5 alone, it doesn't look nice, right? Okay. So these type of arrangements, we call it as matrix. We are arranging in row. If you see the first one, we are arranging in a row. Second one, we are arranging as a column. The third one, some rows and some columns are there, right? So what is matrix? The first one is a matrix, second one is a matrix, the third one is a matrix. It is a rectangular arrangement of elements into rows and columns. This is a basic definition of matrix. It is an arrangement, okay? So now, how to find the position? So the first position is, it is in the first row, it is in the first column, right? So we write it as A11. It is the first row, first column. Second one is, it is in the first row, but in the second column. So we write A12. The third one is, it is in the first row, but in the third column, A13. Suppose the next one more number is there, first row, but fourth column, A14, like that you write, okay? Then we come to the second row. Since we are in the second row, you write A21, right? Second row, first column, A22, and so on. Suppose if we have a number Aij, what's the meaning of that, you know? It is in the ith row, but jth column, okay? So that gives the position of an element. See, how to find order of a matrix? First, you find how many rows are there. See, in this matrix A, we use capital letter. Like sets, capital letter use pannola. For matrix, we use capital alphabets. Okay. So in matrix A, first row, second row, there are 2 rows. And how many columns? 1, 2, 3 columns. There are 2 rows, but 3 columns. So we say order of the matrix is 2 by 3. The first number represents number of rows and the second number represents number of columns. Okay. See the next one. There are 2 rows and 2 columns, right? So it is a 2 by 2 matrix. We say it is a 2 by 2. You write 2 into 2, but you read it as 2 by 2. We say, or a room or a dimension, we say 10 by 8, right? 10 by 8, meaning length 10, breadth is 8, like that. Okay, here number of rows and number of columns. Suppose the order is m by n. I don't know, there are m rows and n columns. Okay, so that is the order. And one more thing, please listen. Suppose in a 2 by 3 matrix, how many elements are there, you see? 1, 2, 3, 4, 5, 6. Any easy method? Yes, you just multiply 2 into 3. What is 2 into 3? 6. Yeah, 2 by 2 matrix, 2 into 2, multiply 4. There are 4 elements. Suppose there are 12 elements in a matrix. Then what are the possible ways? So what are the possible orders of the matrix? So what are the possible orders are? When you multiply, you are supposed to get what? 12, right? So it can be a 1 by 12 matrix. It can be a 1 by 12 matrix, meaning 1 row, 12 columns. It can be a 2 by 6 matrix. 2 rows, 6 columns. 2 into 6, it is 12. Or it can be a 3 by 4 matrix. Or it can be a 4 by 3. Now just reverse it, right? 4 by 3 matrix. Or it can be a 6 by 2 matrix. Or it can be a 12 by 1 matrix. 1 by 12, 12 by 1, entirely different one. Okay. So these are the possible orders of the matrices you can form. Total number of elements is what? 12. Now, there are different types of matrices. Let us see one by one. First one is row matrix. In the name itself it is there. You can understand very easily. Row matrix. If there is only one row, one row mattu vandana, that matrix we call it as what? Row matrix. Number of columns, it can be any number of columns. Ethana column vanalum varalam, but ore oru row vandana, that we call it as what? Row matrix. See, there is only one row. But how many columns? 1, 2, 3, 4. That doesn't matter. Ore oru row varudhu, so it is a row matrix. Appadina, what is column matrix? Row matrix is only one row. So column matrix means only one column. If there is only one column, we call it as column matrix. See, ore oru column varudhu, number of columns 1. Number of rows ethana venalum varalam. Here in this case 1, 2, 3. 3 rows, but just one column. So we call it as what? Column matrix. Now listen, the next one we study square matrix. You know the difference between rectangle and square, right? Rectangle means it has length, breadth. Square எப்படி இருக்கும்? Length, breadth எல்லாம் சேம் ஆயிரும்ல, அதே போல தான் ஸ்கொயர் மேட்ரிக்ஸ். நம்பர் ஆஃப் ரோஸ், நம்பர் ஆஃப் காலம்ஸ் ஆர் ஈக்குவல். 3 rows, 3 columns, or 2 rows, 2 columns, 2 by 2 matrix, 3 by 3 matrix, 10 by 10 matrix. All these are called what? Square matrix. Number of rows equal to number of columns. It is an example. There are 3 rows and there are 3 columns. Next we are going to see something very important. See, about diagonal. You see, in geometry, for rectangle, you can draw diagonals. Even for square, you can draw diagonals, right? But in matrix, see, if I have few elements like this, can you say what is the order of this matrix? 2 rows, 3 columns, right? And below another one, a 3 by 3 matrix. So what is the diagonal? This is one diagonal, this is one diagonal, right? But in the previous one, 2 by 3, can you find the diagonal? If I draw something, here something is missing, right? So in matrix, you can have diagonals only for square matrix, not like geometry. Geometry, rectangle, square, you can draw diagonals. But matrix, it must be a square matrix. Then only you can talk something about diagonal. Okay, first the square matrix. There are 2 diagonals, but in matrix we consider only this diagonal, and this diagonal has a special name. We call it as principal diagonal or leading diagonal, or we call it as main diagonal. Diagonal nu sonnale indha diagonal da. Only this diagonal we consider. This is called principal diagonal. For 3 by 3, this is the principal diagonal. So 2 things to remember. Diagonal exists only for square matrix, okay? And this particular diagonal, that is called principal diagonal or main diagonal, okay? Diagonal matrix, first of all, it must be a square matrix. Then only you can say something about diagonal, right? It is a square matrix. Except the diagonal, I mean principal diagonal. Except the diagonal, all other elements are zeros. So in this example, you see diagonal elements are 7, 3, minus 6. All other elements are what? Zeros. Even in diagonal, one element 0 doesn't matter. Okay, all other elements must be zeros. Then we call it as diagonal matrix. Suppose in the diagonal matrix, the diagonal elements are same. 7, 7, 7. All other elements are 0. Then we call it a scalar matrix. So scalar matrix, first of all, is a diagonal matrix. Abdina is a square matrix, right? Square matrix. Except the diagonal, other elements are zeros. And one more condition, diagonal elements are all same. 7 na ella element 7 are minus 2 na the diagonal full away minus 2 are. Then we call it as what? Scalar matrix. In particular, if that elements are 1, diagonal elements all 1 varudhu, other elements are 0, that we call it as identity matrix, or we call it as unit matrix, and we denote it as I. I3 na, it is the identity matrix of order 3. I2, identity matrix or unit matrix of order 2. Okay, diagonal elements are 1, other elements are all zeros. Then 0 matrix, or we call it as null matrix. Enna order venalum varalam, but all the entries are zeros. So that matrix we call it as what? 0 matrix or null matrix. So it can be a square matrix or it is not a square matrix. Transpose of a matrix, very simple thing. Transpose, abdi and the row column change panniro. We are interchanging rows into columns and columns into rows. That is called transpose of a matrix. See, A is a matrix. The transpose of A, you denote it as A power T or A dash. That is transpose of a matrix. See, In this example, A is a matrix 2 by 3. First row 2 minus 3 4. Second row 1 5 7. A transpose is the first row you write it as first column. Second row you write it as second column. So you are interchanging rows and columns, right? Row column aidunga. So automatically column become row, right? So that is transpose of a matrix. You can notice one thing here. See the order. A order another 2 by 3. A transpose order 3 by 2. Now A order m by n na A transpose order will be n by m. Abdi reverse. Okay, so that you remember. Then 2 times if you take transpose, you will get the original one, right? A transpose, the whole transpose, it is same as A. And lot of properties there. A plus B transpose. Separately you can give A transpose plus B transpose. Even for subtraction, A minus B transpose is A transpose minus B transpose. But for multiplication, you have to be very careful. AB transpose equal to B transpose into A transpose. So that comes in the reverse order. So we call it as reversal law of on transposes. Okay, AB transpose. A is a matrix, B is a matrix. AB transpose is B transpose into A transpose. K A transpose, where K is a scalar. K is not a matrix. Transpose you can take only for matrix. Number updated, you know. K transpose 2 now 1 by 2 okay. The constant you write as it is, transpose you take only for the number for the matrix. So Ka transpose is K into A transpose. Suppose 2 into 2A, the transpose. You write 2, you write as it is 2, only for the matrix A you take transpose. Identity matrix, if you take transpose, you will get identity matrix itself, okay. Then triangular matrix, a square matrix. You see, this is the diagonal. Diagonal's upper part, you can see a triangle. Here you can see a triangle. Lower part also you can see a triangle. If we have non-zero elements only in the lower part, the diagonal order, lower part la mattunda non-zero elements varudhu. That means upper part full away another 0. Lower part la you have non-zero elements, then we call it as lower triangular matrix. Abdina upper triangular matrix enava irukum? Diagonal order, upper part you have non-zero elements, lower part ella element enava irukum 0, okay. So lower part fully 0, upper part alone you have non-zero elements, so that is called upper triangular matrix. Then negative of a matrix, it's very simple. What is negative of 5? Negative 5, minus 5, that's all. So A is a matrix, negative of A means minus A. You change the sign of every element. All elements sign a change pannunga. So that is negative of a matrix. Equal matrix, when can you say two matrices are equal? Very important. Two things, orders must be same. And the rendu matrix order same arukono. Second condition, corresponding elements are equal. Here two matrices given. First one is a 2 by 2 matrix. Second one is also a 2 by 2 matrix. Then the corresponding elements must be equal. First element is equal to first element. That means you can say A equal to 0. Second element is equal to second element. 0 is equal to B. And third one is equal to the third one. So C equal to minus 3 and 7 equal to D. Okay, so that are called equal matrices. So two conditions for equal matrix, the orders are equal. First, the orders must be equal, and the second condition, the corresponding elements are equal. Then addition of two matrices, very simple. If you want to add, suppose A is a matrix 2 1 minus 1 3 2 5, and B is another matrix, say 0 1 2 minus 1 3 4. If I want to find A plus B, just add the corresponding elements. First, adukku munnadi add pannanona rendu matrix order same ah irukanum, ore order ah irukanum. Here A is a matrix of order 2 by 3, right? 2 rows 3 columns, 2 by 3. B order 2 by 3 da, only then you can add it. Rendu matrix equal na order same ah irukanum, correct? So same way, to add two matrices, the orders must be same. Now what do you do? Corresponding elements add pannunga. First you add 2 plus 0, it is 2. Second elements, 1 plus 1, it is 2. Third element, minus 1 plus 2, it is 1. Now we come to the second row, 3 plus minus 1, it is 2. Next one, 2 plus 3, it is 5. Last element, 5 plus 4, it is 9. Just to add the corresponding elements. Same way subtraction. corresponding elements you subtract. Suppose I want to find A minus B. So how can you find A minus B, you know? First, again, you check whether the orders are what? Same. Now to subtract, corresponding elements you subtract. See how to find A minus B. The same example we take. First one is 2, here 0. 2 minus 0, it is 2. Next one is 1 minus 1, 0. Next one, minus 1, minus 2. You are subtracting, right? A minus B. Minus 1, minus 2. It is minus 3. Now come to the second row. 3 minus. There we have minus 1. 3 minus minus 1. Minus minus is plus. So 3 plus 1. It is 4. Then 2 minus 3. Minus 1. 5 minus 4, it is 1. So like that you can add, you can subtract. Orders must be same, then the corresponding elements you can add or subtract. But multiplication is something different, and that is a very, very important thing. Please listen. Product of two matrices. You can't simply multiply any two matrices. Suppose a 2 by 3 matrix, another 2 by 3 matrix. You can add them, you can subtract them, you can equate them. Even you can multiply by a scalar. But here we are multiplying two matrices. Multiplication by a scalar is no problem. Suppose A is a matrix, 2 minus 1, 3, 5. A is a matrix given. Suppose I want to find, say, 3A. This is scalar multiplication of a matrix. What do? You multiply all the elements by 3. Negative of a matrix we studied, minus A. Change the sign of every element. Same way, 3A means you multiply every element by 3. 3 2s are 6. 3 into minus 1, minus 3. 3 3s are 9. 3 5s are 15. That is scalar. A scalar and a matrix you multiply. But now, product of two matrices. This is the most important thing. If two matrices are given, first, let us see when you can multiply. எப்போ ரெண்டு matrix multiply பண்ண முடியும்? Second, எப்படி multiply பண்றது? How to multiply? Both I am going to teach you. Please listen carefully. You can't multiply any two matrices. Order same வந்தா multiply பண்ண முடியுமா? Not sure. We have to check some condition. Okay? ஒரு 2 by 3, இன்னொரு 2 by 3. Can you multiply? Please listen. Condition number 1. First matrix is m by n. Second matrix order p by q. N must be equal to p. That is condition number 1. N is equal to p. N is equal to p. So what's the meaning of that? N represent what? Number of columns of first matrix. Number of columns of first matrix must be equal to number of rows of the second matrix. First number represent row, second number represent column, right? Here n equal to p. N is the number of columns of first matrix. P is number of rows of the second matrix. That two must be equal. Then that is first condition. Then how to multiply, I'll tell you. Then what is the order of the answer? AB கண்டுபிடிக்கிறீங்க product. The final answer or order என்ன வரும்னா first and last m by q. M by q இருக்கும். That is order of the product AB, right? So in this example, these two are not same. So you cannot multiply a 2 by 3 matrix and 2 by 3 matrix. Okay, that you cannot multiply because they are not equal. But can you multiply a 2 by 3 and 3 by 2 matrix? Orders are different. You can't add, you can't subtract. Can you multiply? Yes, you can multiply. These two are equal. You can multiply, right? Number of columns of the first matrix, number of rows of the second matrix equal. You can multiply. The product, the order of AB. Here AB exists. And the order of AB is first and last. So it is 2 by 2. So, okay, so now just I explained whether product exists or not. You can check it. Okay. So in general, AB not equal to BA, that is matrix multiplication is not commutative. Now please listen here. Suppose a matrix A, its order is 2 by 3. A is a matrix of order 2 by 3. B is a matrix, we don't know its order. We want to find that. AB product exists, அதோட order கொடுத்துட்டாங்க 2 by 4. I want to find the order of B. I'm taking the order as m by n. You know, AB exists, naale these two must be same. So m is equal to 3, correct? M equal to 3. Answer order first and last 2 by n. 2 by n. Instead of n we have 4. Appo n value 4. So you can say the order of B. Order of B I have taken as m by n. Appo m value 3, n value 4. So the order is what? 3 by 4. Then transpose of a matrix, you know, we studied, you have to interchange rows and columns, so that part. Now, only for matrix multiplication, just I want to give you a few questions. Okay, please listen carefully. How to multiply two matrices? Suppose 2 3 1 5, this is one matrix. I want to multiply by 1, minus 1, 2, 2, 3, 1. First, let us see, can you multiply? What is the order of the first matrix? It's a square matrix, 2 by 2. Second matrix order, 2 rows, 3 columns. Yes, you can multiply. What will be the order of the product? 2 by 3, right? 2 rows, 3 columns. So please listen how to multiply. Listen, entirely a different one. You take the first row, first column. What do you mean by that? First row, first column, 2 into 1 plus 3 into 2. First row, first column, 2 into 1. 2 into 1 is 2 plus 3 into 2. 3 into 2 is 6. That is the first element. First row, first column. Now, next what you do? First row, second column you take. First row, second column. First, what we did first? First row, first column, right? First row, first column. Now, first row, second column you do. Same type multiplication. First row, second column. So what we mean by that? 2 into minus 1. 2 into minus 1 is minus 2. 3 into 3. 3 3s are 9, right? So first row, first column, then first row, second column. Now next we are going to do for the third one. So for that what you do? First row, third column. First row, third column. First row, first column, first row, second column. Now first row, third column. See what is the meaning of that? 2 into 2. 2 into 2, it is 4. Then 3 into 1, it is 3. So first row is over. First row, first column, first row, second column, first row, third column. Now we come to the second row. Suppose there is one more column. First row first, first row second, first row third, then first row 4, you write here. But that's all here, everything is over. Now you come to the second row. Second row, first column, second row, second column, second row, third column. So listen very carefully. First, second row, first column, second row, first column. So 1 into 1, 1 plus 5 into 2, it is 10. Now first row, second column next. First row, second column. Please listen. First row, second column. What we mean by that? First row, second column. Sorry. First row, second column. First column we finish. First row, second column. So what is that? 1 into minus 1. Minus 1 plus 5 into 3. 5 3s are 15. Now the last one, what do you do? Second row, third column. Second row, third column. Second row, third column. 1 into 2, it is 2. 5 into 1, it is 5. Now just to simplify this, so what you are getting? 6 plus 2 plus 6, 8. 9 minus 2, 7. Again 7. Here 11. Here you have 14. Here you have 7, right? So like this you can find the product. So there are different type questions there. Please listen. Some of the questions will surprise us. Look at this. 2 minus 1, 3. Another matrix, 1, 5, 2. What is the order of the first matrix? It is a row matrix, right? 1 row, 3 columns. 1 row, 3 columns. Second one, 3 rows. 1, 2, 3. 3 rows, 1 column. 3 rows and just 1 column. Can you multiply that? Can you multiply them? Yes. First one is 1 by 3. Second one is 3 by 1. Yes, these two are equal. You can multiply. What will be the order of the product? 1 by 1. 1 by 1. Now only one element you are going to get, right? See how to do this. First row, first column. That's all. First row, first column. See what you get? 2 into 1. 2. Minus 1 into 5. Minus 5. 3 into 2. 6. That's all. Just you are going to get one element. See what is that? 6 minus 5. 1. 1 plus 2. 3. It's a single element. 1 by 1. Right? Same thing if I take in the reverse order. I am taking 1, 5, 2 first. Column matrix. 1, 5, 2. I multiply by 2 minus 1, 3. Can you multiply? Check it. What is the order of the first matrix? 3 by 1. Second one, 1 by 3. Can you multiply? Yes. What will be your answers order? You are going to get a 3 by 3. 9 elements will be there. Right? Just we reverse the order, entirely different, right? So now please listen how to get that 3 by 3. First row, first column, 1 into 2, 2, that's all. First row, second, 1 into minus 1, minus 1. First row, third, 1 into 3, 3. All three numbers are different. Don't add them. Okay, you are supposed to get a 3 by 3. That's why you check that first, then you will not get any doubt. You learn enna pannu, elladhum add panni sometimes you write. Okay, leave space, enough space for that. Come to the second row, 5 is there. Second row, first column, 5 into 2, 10. Second column, second row, second column, 5 into minus 1, minus 5, then 5 into 3, 15. Now come to the third row, first column, 2 2s are 4. Third row, second column, 2 into minus 1, minus 2, 2 into 3, it is what? 6. Okay, so like that you can multiply. Okay, now let us see just one more question of the same type. Look at this one. 2 minus, or we take 2, 1, 3, 2 minus 1, 2, 2, 1, 3. I want to multiply this by 3, 1, 2. Please listen carefully. What is the order of the first matrix? 3 by 3. Second one is 3 by 1, right? Yes, you can multiply. Your answer's order will be 3 by 1. 3 by 1. So first row, first column. Please listen. First row, first column. First row, first column. Corresponding element. 2 into 3, 6. 1 into 1, it is 1. 3 into 2, 6. Everything together, one term. Now come to the second row. Second row, first column. 2 into 3, 6. Minus 1 into 1. Minus 1, 2 into 2, 4. Last one. Third row, first column. 2 into 3, 6. 1 into 1, it is 1. 3 into 2, 6. When you come to the next second row, you write the answer in the second row. Okay. So when you simplify, you are getting 13. Then second, what you are getting? 10 minus 1, 9. Then you are getting 13. Okay. Now let us see just one final example. We take two 3 by 3 matrices. Okay. A is a 3 by 3 matrix and B, I am going to give a 3 by 3 matrix. Let us find AB and BA. See, A is a matrix 1, 2, 1, 2, 3, 1, 4, 3, 2. And B is a matrix 1, 1, 2, 1, 1, 2, 2, 0, 1 and 4, 1, 5. So let us find AB. And BA you can find of your own. Okay. See, first 1, 2, 1, 2, 3, 1, 4, 3, 2. A into B 1, 1, 2, 2, 0, 1, 4, 1, 5. So the calculation part you do very carefully. Okay. Now please listen here. So here first row, first column, first row, first column. By this first row, first column. So 1 into 1, it is 1. Then 2 into 2, it is 4. 1 into 4, it is 4. Now first row, second column. 1 into 1, it is 1. 2 into 0, it is 0. Then 1 into 1, it is 1. Now first row, third column. First row, third column. 1 into 2, 2. Second element, second element. 2 into 1, it is 2. Then third one, 1 into 5, it is 5. So that's all about the first row. First row, first column, first row, second column, first row, third column. Okay. Now let us see. Now we move on to the second one, right? Again you start with second row, first column, right? Second row, first column. So 2 into 1, 2. 3 into 2, 6. 1 into 4, it is 4. Second row, first column. Then second row, second column. 2 into 1, 2. 3 into 0, it is 0. Plus 1 into 1, it is 1. Now second row, third column. 2 into 2, 4. 3 into 1, 3. 1 into 5, 5. That's all about the second one, right? Now you move on to the third row. When you move on to the third row, here also go to the third row, right? Now, third row, first column, third row, first column. So, 4 into 1, 4, 3 into 2, 6, 2 into 4, 8. Last one, 4 into 1. Now third row, second column. 4 into 1, 4, 3 into 0, 0, 2 into 1, 2. And the last one, third row, third column. 4 2s are 8, 3 1s are 3, 2 5s are 10, right? So now just addition, you do it very carefully. First one is 9, second one 2, then 9, 12, 3, again you are getting 12, right? 18, 6, you are getting 18, 21, right? Yes. Like this you can find AB. Same way I want you to practice BA. BA means what you do? First you write B. B first then write A. Don't simply multiply term by term, row by column. Okay, so hope you understood all these things about matrices, matrix operations, how to add, how to subtract, how to multiply by a scalar. When can you say the matrices are equal? So with this idea, you practice more questions. I'll meet you with some other basic ideas from some other chapter in the next video.